Hello friends, welcome back. I was hoping to explain a critical case of time travel possibility in a short series of two videos. This is the part 1 and let's get into it. Firstly, there was no evidence for time travel in macroscopic world with the laws of classical physics. Of course, we don't have a Hulk in our world, but as a matter of common sense, we all know that time slows down in the presence of strong gravitational field, like we can say black holes. So, we will try to understand this in microscopic level. This means we are deviating from classical physics and going to a fairly quantum world. The first rule we know in the microscopic sense is the uncertainty principle. The more accurately we know a quantity, the less accurately we know the other. From this, we can say that vacuum in space is not really vacuum at all. If it is really empty, the value of gravitational field and electromagnetic field must be zero, which is impossible as stated by uncertainty principle. There must be a certain amount of uncertainty, or more formally known as quantum fluctuations, in the value of the field. These fluctuations can be regarded as a pair of particles appearing at a place and then annihilate and reappear at another places. Now, these quantum fluctuations account for the particles from moving from a point A to point B. This path from A to B does not have a single history, as in classical theory. Instead, it has to follow every possible path in the space-time, which again attributes to uncertainty principle. The probability of all these paths is 1. Logically, it implies to be like path integrals that we use in mathematics. This is known as Feynman sum over histories. One has to incorporate this principle to define any kind of time travel in quantum theory. We will see how this principle explains a possible idea for time travel in part 2. Thank you.